Hello and welcome to this first introduction tutorial from OpenShading.com. My name is Thomas Dinges and today I would like to give you an introduction to the new website and also show you how you can get started with cycles and OpenShading language. So first of all, the new website contains several information resources about the cycles render engine and about OpenShading language, which is the primary focus of this website. There are not many OpenShading language capable render engines on the public market yet, so I cannot really compare if the shaders are working on other renderers, but this will probably change in the near future, and there are also some information about render engines which are in the process of integrating OSL into their engine. We have some getting started guides and also example shaders, so you can check that out and get up and running with the language and see what is possible. If you are already familiar with a shading language but not familiar with cycles, I recommend you to check out the cycles category on the website, and we have some resources here where you can find Blender video tutorials about Blender in general, how to get started, about the feature set and so on. So you can check that out if you want to get up and running with Blender. You can also contact me if you would like to give me some feedback on the website or recommend some improvements. And I'm also looking for contributors. So if you have written a nice OSL shader which you would like to share with the public, or you have tips or even a tutorial, feel free to contact me and I'm happy to feature it on the website. Okay, but let's get started with Blender and I will show you how you can start writing your own shaders there. I have downloaded a recent Blender build. You can find a link to that on the website and in the video description here. And first of all, I have to change the render engine to Cycles Render, which is the new engine of Blender and also the one which supports OSL. Next, I have to change the shading system to OpenShading language here. Now I can configure my workspace a bit. I will just drag this up a bit and press the triangle here on the left down corner, drag it, and I can change the editor type to a node editor here, in which we can see our shader. I press use nodes, and as you can see, per default we have a simple diffuse closure and a material output here. I will change the other editor to a text editor, so I can directly write my OSL shaders inside of Blender. This is not necessary. You can also load a OSL shader from your hard drive, but for this tutorial it's easier to write the shader directly inside of the application. Okay, there is some basic syntax highlighting here as well, but it's for Python, so the highlighting will not be really accurate, but still it will give some improvements over plain looking text. Okay, first of all I will include the std OSL header file, which declares some closures and functions which are needed for our shader. Then we have the basic shader structure, and first of all we have to determine the type of the shader. Now if you have read the OSL language specification, which I highly recommend, then you know that there are 4 different types of shaders in OSL. There's the surface, the volume, the displacement, and the generic shader type. In Blender you can only use the generic shader type because the actual type of the shader is being determined here inside of the material output node. So all the nodes here, all the shaders are from type shader, and then dependent on where you connect the node, it then translates it to a surface, volume, or a displacement shader. Although volumes are not supported yet in cycles. This is for the future. Okay, so we need a name for our shader. Let's just call it first example. And then we can define the input and output variables. So let's get started with something really simple. let's write a pass-through material. So you have input color, and the output of the shader just takes this input and outputs it. So we define a new variable from type color, and we give it a name. Let's call it col1, and I assign a new color to that. That's the default of this value. So let's take, for example, 0.8, 0.6, and 0.4, which are the three RGB components. And then we have an output color, which we call cal2. And we also assign a default to that. And let's just make it 0.8. You don't have to provide all three RGB components if all of the three components are the same. Then you can just write color and then 0.8, for example. Okay, let's, oh, this is wrong. I need a comma here, not a dot. Okay, so this is my basic shader declaration. And now I can write the actual execution code. So I add two brackets here. And let's start. So I will just output the input color. So I take the output, which is cal2, and assign it to the input cal1. Okay, so let's go to script. You can find this add node menu here, in where you have access to all kinds of shaders and materials of cycles with Shift A on your keyboard, Shift A, and then I choose script. Now I choose internal because I want to use this text block here. I go to text, and as you can see, it automatically compiled the OSL shader. And now I have my input color, which also has the defaults we declared, and then the output. So I will just connect that with the left mouse button and drag it over to the input color socket on my diffuse shader. And let's start rendering. And as you can see here, you have your basic color now. Congratulations, you just wrote your first shader. But let's do something more complicated. Let's write a small and easy 4D noise pattern. So for our 4D noise we need a time variable so we can animate the noise. And I can do that by declaring a float variable. Let's call it time and assign a default of 0.0 to it. We don't need the cal1 input anymore, so I can just remove that. And now I can declare the noise. For that I call a in OSL inbuilt noise function. And first of all I have to determine the type of the noise. We take a simple Perlin noise type in this case. Then we have to declare a vector here. So I pass over the p variable, which is one of the OSL shader globals. You can find more information about that in the specification PDF as well. P in this case is just the, basically the point on the surface which is being shaded by the render engine at the moment. And we also take the time variable from above. Let's check it again. Okay, this looks okay, and I recompiled my shader. And now the shader changed, so I have my time input now and the output again. But this time it won't output a simple color, but it will output this Perlin 4D noise. So let's start the rendering again, and now you see the procedural noise here. If I change the time value now, you see this is changing. And you can animate that, for example, now and use it for some nice basic noise effects. Okay, that's it for now. I hope you enjoyed this first introduction tutorial and you know some basics now. I recommend you to check out the example shaders on the website. You can download a few of them and just load them via the external function here in the script node and can play around with it, change the source code and see what you can come up with. So thanks for watching and see you next time again when I will provide a new tutorial for OSL and cycles. Bye.